extra video and show you what's going on. Basically, what organic means is that it contains lots and lots of carbon, right? Well, sometimes we have 1 carbon, 2 carbons, 3 carbons, 4 carbons, and we actually have a name or a prefix that describes the number of carbons. The prefixes are meth, F, pro, but, pent, hex, hep, and you can guess. It follows the kind of at the end, it follows the covalent side of things towards the end. One of my colleagues told me, hold on, many elephants play ball. Many elephants play ball is how he remembers the first 4. Meth, F, pro, but. But is the one that most people are like, I cannot remember what 4 carbons means, but it's the word but, the prefix but means there are 4 carbons. So these are basically telling you the number of carbons. The second side, which is the last half, the suffix, is telling us what kind of bonds are present in that molecule. So if it says the word ane, so if we're, that's the test, reviewing in teal. Spoiler alert, that's what it looks like. Okay, so this right here is meaning that they're all singly bonded. So ane means single bonds. And so the way that you figure out the number of hydrogens that are connected to the carbons, because basically organic is a bunch of carbons, they're carbons and hydrogens, and that's basically it. We're going to see an alcohol with an oxygen involved as well, but it's just a bunch of carbons and hydrogens. So if I have 1, 2, 3, 4, 5, 6, 7, 8 carbons, and I end the word, the name of the word in ane, I'm telling you that I have lots of single bonds. Everything's got a hydrogen on it, or more. The way you figure out how many hydrogens are you take N, which is the number of carbons, you multiply by 2, and you add 2, and that gives you the number of carbons. So let's do a practice round of this one. If I have methane, how many carbons is that? Meth. 1. Okay. So the formula for methane, I'll write this around the board. Methane. This means 1 carbon, and ane means 2n plus 2 for the number of hydrogens. Okay? So if I have 1 carbon, n is 1. 2n times 1 plus 2 is how many hydrogens? 4. Okay? So what's the formula for methane? C1H4. But nobody writes the 1, right? It looks stupid. Yeah. So it's CH4. That's methane. Let's try again. Let's do ethane. Okay, so ethane, how many carbons? 2. How many total hydrogens? How many? 6. So you're doing 2 times 2 plus 2, 6, right? So that would be C2H6. So let's draw that. C2H6. Let's draw it like we did back in the day with Lewis dot structures. So all you're going to do is connect your carbons. Carbon bonded to carbon. There's our 2 carbons. Where do you think all those hydrogens are going? 2 for each carbon or 3 for each carbon? Because you actually need 4 bonds around carbon. It loves to have octet. So give it all octet, make it look like it's kind of symmetrical. That's ethane. That's it. Okay, so let's do propane. What's propane's formula? How many carbons? 3. So propane, 3 carbons, so the carbons are now 3. And how many hydrogens? 8. C3H8, C3H8. So how would that differ? How would the structure differ? So you have another carbon, so I'm just going to take this hydrogen off, put this carbon here, and then what else? So I took away 1, so I have to give it back, right? So then I'm just going to add a carbon and surround it with hydrogen. That's it. So the anes are all singly bonded, right? Now we're going to look at ones that are doubly bonded. And that just means carbon-to-carbon bonds. Instead of being a single bond, they're going to have a double bond on there. So the ending changes when you want to say it has a double bond. Instead of saying an ane ending, it's an ene ending. E-N-E, ene. So this means double bonded. And the carbons, instead of being 2, I'm sorry, the hydrogens, instead of being 2n plus 2, are just 2n. That's it. So 2n, this was 2n plus 2. So let's go back to the drawing board. This is drawing board. And look at the, let's do ethene. Ethene. You have to be very, very clear on what you're saying, right? How many carbons is this? F. 2 carbons. How many hydrogens is this? What's the formula for it? So it's 2n, right? N in this case is 2. So that's 2 times 2, which is 4 hydrogens. So what's the formula? C2H4. Okay, now let's draw that. Knowing that it has a double bond, okay? Ethene has a double bond. What does that guy look like? We're going to start with in the middle. Double bond, right? Two C's and a double bond because we have to have a double bond. How many hydrogens on each one? 2, because we only have 4 to work with. We have to make it symmetrical. We have to have everybody with octet, and we do. We're good here. 2, 4, 6, 8. Great. 2, 4, 6, 8. Great. And if we actually counted our Lewis-Dot model, the valence electrons, it would agree as well. So ethane has all single bonds. Ethene has a double bond, not all, a double bond. Guess what ethine has? Ethine would have a triple bond, okay? And they are so nice. They go in order, alphabetical order. I don't know if you realize that. Ane, single bond. Ene, so A to E. Double bond to Y for ein is a triple bond. So if you remember ane, ein, single, double, triple, we're good. You okay with that? So let's do the formula first, and then we'll draw the bonding pattern for that. So ethine, F still means 2. Ein means the formula for that is for hydrogens are 2n minus 2. I didn't show you right there, but it's 2n minus 2. So then how many hydrogens do we have? 2. So 2 times 2 for the 2 of C, carbon, minus 2 is 2. So then what's the formula? C2H2, right? C2H2. Draw C2H2. What's it going to look like? What's in the middle? A triple bond. And what's on each side? So a hydrogen on each side to give us a net of 2. C2H2. So it looks like. Cool with that? It's just a little different. It's not that, I mean, it is a totally new classification of chemistry, let's be honest. There's like majors in this, just organic chemistry. But this is the basics of it, okay? The last one is an alcohol. So we had an ane, ein ending, and sometimes we'll actually have an alcohol which has an oxygen involved, and instead of having those endings, it'll have an all ending. So an example is ethanol. So ethanol, I think it's easier to draw it than to tell you like a little cheat sheet formula for it, because it doesn't always work. F and all. S, we know means 2 carbons. And is kind of like saying ane, right? So we're assuming this carbons have what kind of bonds? Single bonds, right? So I'm just going to put single bonds. And our formula for that was 2n plus 2. But I'm going to modify it and kind of tell you what it means. Instead of having all H's, there's one part that has an OH ending. So it's actually 2n plus 1. And then this guy means I need an OH on the end. That's the only weird one, but I think drawing it actually helps more than actually giving you that little 2n plus 1 thing. So let's look at the sketch first. How many carbons? 2. And everybody's going to have single bonds, so we're going to have hydrogens everywhere. H, 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 H. And I want to put an H here, but I'm not allowed to. I have to include the all here. I have to include an alcohol. And it could be anywhere. I'm just using this terminal end, OH, like that. Or you can do O bonded H. So instead of being just OH, you could do bonds. Actually indicate what's happening here like that. Okay, let's practice this. You guys have this practice questions on your sheet. Who does not have this? I only have, I have quite a few left. Who doesn't have this? I'm actually, I have more. Yes. So, a couple of these guys. The ones where it says writing the formulas to names and back, this is what I'm doing next. So is this the first one? Yeah. Propane. What's pro mean? Pro means 3, so carbons have 3. There are 3 carbons. Ane. Single bond, so how many H's? 8. 2n plus 2 is 8, right? So this is a 2n plus 2, 1 for the number of hydrogens. So that's carbon 3, so that's 6 plus 2 is 8. Great? Okay, propane, done. Pentane. Pent. 5. Carbons have 5. Ane means single bond, so 2n plus 2. Do that in your head. Say again. 12. Hydrogens are 12. Next, butane. C4. So you're doing in your head 2n plus 2 because it's an ane ending, so that would be 4 times 2 is 8 plus 2 is 10. Okay, this one's funky. Do you notice the ending? So what is that ending telling us? Double bond. Okay, so we already know that's a double. And this number is telling us where the double bond is. It's on the second carbon. That just helps us place it if we ever need to. And this one it wants us to. So how many carbons across? So bute, right? Bute needs 4 carbons, so that's C4. And then it's ene, so how does the number of H's change? So it's just 2n, right? So that's how many hydrogens? 8, so that's H8. Now I want you to draw it, and I want you to draw the double bond on its appropriate location, because this is just the formula, which is cool. We got the formula. But to draw it, you would draw 4 carbons. Where do you put this thing? The double bond. Second carbon, so it's not between the first and second, it's actually on the second to the third. It's like when you're counting across. The second one to the third. And then what do you have to do? Add hydrogens everywhere. So every carbon must have 4 bonds, right? So the ternary, or the, whatever it's called, terminal end has 4. The other end also has 4. But what's different about this one in the middle, the second one? How many H's need to be attached to complete its octet? Just 1, right? And I'm going to put it on top. It doesn't matter if you put top or bottom. It can go either. So that's 1, 2, 3, 4 on that carbon. So what do I need on this one? Just 1 again, because it's going to have octet by 1, 2, 3, 4, so it's 8 total. And I just made them opposite. It doesn't matter as long as you're attaching the numbers correctly. Okay, butanol. Butanol. What's bute mean again? 4 carbons. So do we have an estimate on our H's and maybe what this all ending means? Maybe 10, right? So you're saying in your head 2n plus 2. But it's actually one of those H's are replaced with an OH. So that's going to be what we see for. So that's 9, H9, and then you can just on the end put the OH like this. I know some there are 10 H's, but I want you to notice the alcohol group is its own special group, and we kind of keep it to the side. So that would be looking similar. Well, kind of already have double bonds in there. So we've got H's everywhere here. So that's H, 1, 2, 3, 4, 5, 6, 7, 8, 9. What's here? OH. Okay? Now you guys try the ones that we're saying you try. Try with the partner. Take 5, 6, 7. Rejoin your partner. Amy? What's up? What's the first one, guys? C6H14. Because you got to multiply by 2 and add 2. Okay? I think they're very intuitive once you get there. H14. What's the next one? We may have just done this. Oops, H5. We did bute. Okay? Octane. So you added 2. Good. Propine. Good. That's like, reminds me of porcupine. Propine. Okay. Pentanol. Nice. Pentene. You're awesome people. Okay. We have about 10 minutes left. What I need to do is I need to converse with some people on Mythbusters and skits. So skits, what I need from you. If you have it written, you can put it in the box when it's done. If you need to send it to me, send it to me. But that's something that it can be very simple. Please don't put a lot of time. I mean, do put time into it, but don't let that be a focus. I want you to have fun in terms of making the skits so you're understanding how to mentally understand how to do nomenclature. It doesn't have to be a big shindig, but we're going to perform for each other. I was going to do it today, but I think we need to do it probably Monday. And that is going to be something that will serve as a review for us. Okay? And if you read into the details in the back of the polyatomic ion list, it says like have some creativity, have some fun, have some background in there. It does not have to be overpowering that, okay? It can be simple. And it can be fun. It doesn't have to be like you're teaching a 5th grader, but I say keep it on 5th grade level, like as if you were really trying to explain it to them in detail. Second, Mythbusters. Mythbusters, the research brief, what do I need to explain on that? Like what do I need to explain? What are we confused on? What are our questions? Wait, what kind of research? So, for example, if I were doing, I don't know, if I feed a cat this, does it blow up? Okay, let's say that's my Mythbusters project. I'm just saying. Or if I wanted to do, let's go with the educational one, Schrodinger's half-life experiment, right? I would research, first of all, what's the chemistry behind my topic? You know, for example, half-life. How does radioactivity occur? What is the half-life of the substance I'm using? What is the life of a cat? I'm trying to think. I'm really trying here. But you're really going for the science behind the scenes. And then, you know, I shouldn't have to read between the lines. It should be hit me in the face, the science. I know basically what's going to happen in all of your experiments. But I want you to figure it out. I want you to experiment. I want you to try variables. And if you propose maybe a one-variable experiment where you're saying, you know, we're going to try hot versus cold, think about what other variables you can change. Maybe you can change the pH. Maybe you can change the, not only the temperature, but the substances you're using. Maybe you can, let's see here. Somebody give me their idea. Hair dye. This is the O. You guys are going to probably look up the chemical composition of all Kool-Aids, all food colorings, figure out their ionic or covalent, figure out how they're going to bond with the hair, figure out the chemical composition of the hair that you're using versus maybe a Barbie. You can do like natural hair versus Barbie versus somebody who's out in the sun all the time. How does it affect it? Those are 3 different variables. And I'm not saying like you're going to have, you know, 50 variables, but it's okay to not only have one independent and one dependent. You can basically run 3 or 4 experiments within your whole experiment. And I expect it to be high level. So if you're just testing one thing, you're looking for one thing, that's kind of 5th grade. So I want you to look for more. So like you guys are looking at different candies and seeing how it impacts the explosiveness of something, right? Okay, so they're going to probably test, I don't know, 10 different candies to look for sugar content and the different types of sugar, high fructose syrup versus natural sugar versus the sugar in the raw versus, you could try like 7 different sugars at least. Okay, so think like that, and I'll give you as much feedback as I can this weekend and into Monday, because I want you guys to start thinking about the experiment. Do not put the experiment in there, though. The experiment comes into the experimental design, which you can look into, but I don't want to know what you're going to do. I want to know the background, okay? And if you don't find enough in resources, just email me and I'll try to find some that I'm aware of. But Chem Matters has a bunch. The Coxman website has a bunch. If you find something that's on Wikipedia, go to the bottom to where the resources are, and those are going to be the more of the reliable sources that you would be looking into. Okay, so if you have, you know, a little bit of time, you need to talk to your Mythbusters partner, talk with them now, but also think about your review. I'll pull it up for you. Yours should be good. Okay. I'm looking at your last. But you got to come to me. Okay. Never mind, we'll do this later.